Good afternoon and welcome to Across the Fence. I'm Jolene Whitney. If you were with us yesterday, we introduced you to a UVM professor and student who studies whales. On today's program, we again dive below the briny deep to find out how scientists track the song of humpback whales. Here's Keith Silva with part 2 of our whale tale.
To catch you up on what we learned on yesterday's program, number 1, only male humpback whales sing. Number 2, the songs can go on for hours. And number 3, no one really knows why humpback whales sing at all. To answer these questions, I'm joined by Laura May Cajado, an assistant professor in the UVM Department of Biology, and also joining us for the second part of our discussion is Megan O'Connor from Rutland, Vermont. She's in an accelerated master's program studying marine biology at UVM. Welcome to both of you.
Thank you.
Laura, when did people start researching whale song? And I understand there's a Vermont connection.
Yeah, so in the 1970s, that's when the first description of the song was made by Roger Payne and Scott McKay. And Roger Payne is a Vermonter that sadly passed away this year, but he left an incredible, legacy to all of us. Since the 70s, we've been studying these songs, and the description and the nomenclature that he generated is what we still are using today to study these whales. So incredible contribution and, very beloved scientist.
And he lived in Woodstock, Vermont.
Yeah, he did.
Lived in Woodstock. How does vocalization, animal vocalization, become song? When does it cross over to becoming song?
So the way that we define a song, and same definition will apply to birds, is when you have a series of components that are organized in a hierarchical way. So in the case of whales, we call the largest unit the theme, that consists of phrases.
Okay.
Right? So a theme will be a repetition of multiple phrases. Sometimes it's the same phrase, sometimes it's one or two phrases in the same thing. And each of these phrases has a unit, a smaller, kind of component that defines the phrase. And so when these themes are sung in a particular order, right, and over and over and over, that's what we call, hierarchical complex song.
A song.
Yeah.
And you said that each whale is singing the same sad song, just their own version of it.
Yeah, so one of the aspects of humpback whales is conformity. So basically, within a reproductive population, the whales that arrive there, they come with slight variations from the previous year song, but it has many components of last year. So they slowly begin to converge in the same hit song. And by the peak of the season, all the males are singing exactly the same song. So what we don't know is if this is a song that is function is attract females, what is exactly the females listen to? How can the female tell males if everybody's singing the same song?
Right.
And if this is the function is male-male competition, what are the components that male are evaluating to say, oh, guy, that's a very good singer, so I better stay away, right? So it's possible that it's a combination of the two, and we assume these these hypotheses are applicable to humpback whales because of what we know and we have learned in songbirds.
One of the things that we were talking about while we were getting ready was the fact that unlike songbirds and being able to say, aha, that bird is singing right now and we know what his or her song is, you can't do that with whales. There are no cameras under the water. What does it sound like under the water? I mean, that's where your research takes place. You go under the water. Is it loud, quiet? What's it sound like under there?
So we cheat because we are actually using hydrophones, so the version of microphones for water.
Yep.
And so we stay on our boat, and we use our recording system to get a sense of where the whales are. We have sometimes 2 hydrophones or 4 hydrophones that allows us to kind of get closer to a specific singer. Even though there may be multiple singers, that helps us to kind of narrow down where the singer might be.
Right.
So we use this hydrophone, and it's usually, but depending where we are, can be very noisy because there are other animals also producing sound. We also have our other recorders that I showed last time, the sound trap, and those can pick up also anything. And we drop these in areas that are closer to coral reefs. So we usually can hear fish, which are incredible. They produce a lot of sounds, and they can be as fascinating as the humpback whales. We can also get snapping shrimp. sea urchins if they're moving around. So that's a sound that is a byproduct when they move. And dolphins, of course, which
And
are also
dolphins,
fascinating.
of course. And mentioning dolphins is a good way to bring Megan into our conversation. The recordings that are gathered down in Costa Rica and you said it was
Panama,
the Pacific
Panama,
side
and the Caribbean.
the Caribbean side. Thank you. And the Caribbean side are brought back here and analyzed here and put into a visual display. And our director, Chris, will bring that up. So there is the display. Megan, this is where a lot of your work comes in. What are we looking at?
So this is a spectrogram, and this is very typical of what we'll be looking at in the lab, and it basically visualizes the sounds that the hydrophones and the sound traps are picking up. So as you see it scrolling across, these are the whistles over time. So we can take a look at the whistles, and the lines going up and down are the actual whistles and the frequency that they'll be at. So that's how we can kind of categorize a whistle, is when it goes up and down in frequency,
So
like
those
a song.
yellow lines are the whistles.
Yeah, the yellow lines.
Okay. We mentioned that you're from Rutland, that you're a Vermonter, proud Vermonter. What do you tell your family and friends when you say, I study whales at UVM?
I mean, the usual question is how, but I usually try to explain that most of the work going into studying the whales is not done when we're anywhere near them. I mean, most of my work so far, I haven't been to the field yet, has been spent looking at the spectrograms and collecting data from those, which is unbelievably interesting to me. But I do love to kind of advertise that it's possible to, you know, follow like the path of marine biology, even if you aren't exposed to the ocean all the time.
Right. Nowhere near an ocean, but somehow you can still study the ocean from far away. There's another spectrogram that we wanted to look at that actually shows these phrases that you mentioned. There they are there. So tell me what we're looking at. What is that phrase? How do you see that? What do you see there, Megan?
So when we look at a spectrogram and we see the whistles again are the yellow lines, visually you can kind of see a pattern. And once you see that patterns of songs start to repeat over and over again, like there's probably like 7 of those lines, we can call that a phrase once we see it enough. And then we see that block get repeated over and over again. So that those 2 phrases are a theme. They're parts of a theme.
They're parts of a theme. And this is how we get a song.
Yes.
This is how we get a song. Laura, how has climate change affected your research into humpback whales?
So we are noticing that, well, climate change, specifically these past years, a lot of our recordings come during the La Niña event, which was the period time that the waters were really cold, and now the waters are warming because we're on El Niño, which is expected to last till next spring. So that can influence how far the whales are migrating. It might also impact how many whales arrive to this area. But in terms of the song and our research, it doesn't really impact because the whales still have to arrive to these places and reproduce, and the males still have to display. So we haven't noticed any particular change related to climate change in the song or the frequency of the song. We do see other more important impacts, which are more related to human noise.
Human noise. You said that through conservation work, the population of humpback whales has increased, and by the increase of whales means there are more people out there who aren't scientists like you looking at the whales. And you said that there's a lot of other boats around when you're trying to work.
Yeah, so one of the incredible things that happened when we discovered the song of the humpback whales because of Roger Payne and collaborators, that served as the important mechanism for people, the public, to understand them and to value these animals, which led to their protection, right? And so since these populations have grown, and especially the population of the southern hemisphere, our population is called the breeding G population, which is the one that I mentioned last time, comes from Antarctica. And this population has grown. So as you know, fisheries industry is declining in many Latin American countries, whale watching has become a very important economical opportunity for them, and it's very valid. And a lot of countries have developed guidelines But you know, one of the things that is hard to control is how many boats can be at the same time around an animal. And that's what we have seen. Sometimes when we're recording, we might have 10 other boats around, and that makes it very hard for us to record. And also, but at the same time helps us understand from the whale perspective, right? Because we're recording all that noise, so what the whale is experiencing. And we just published a paper where we compare the song production of songs before, during COVID lockdowns and after COVID lockdowns, and we noticed that during the lockdowns, the whales were singing 100% 24 hours. But during before and after the COVID lockdowns, there's a drop at the same time where we have a peak of boat presence. So that suggests to us that the whales are making decisions, right, when to sing based on these extra noises, right, in the environment. And we need to incorporate that in management.
Right, right. Megan, do you graduate in a couple of months? Did I have that right? Junior or a senior?
I'm a senior, yes.
You are a senior, okay. Oh, that's right, because the accelerated MA program. What do you want to do when you get done?
I'm not sure yet,
Okay.
but I've loved the research I've been able to do so far as a bit as an undergrad and then going into my master's. So I'm hoping that I'll get to continue that after I finish my master's, whether that's a PhD or any other opportunity I might come across. I definitely want to keep going the same direction.
Excellent. Well, we wish you all the luck.
Thank you.
If you've enjoyed our conversation with Professor May Cajado, you can read more about her adventures, research, and the Whale Lab, where Megan works, in the fall edition of the magazine. The address to read that article is on the screen, and that was written by Josh Brown. And if you missed part 1 of our discussion, visit Across the Fence on YouTube or Facebook by searching Across the Fence on either platform.
My thanks to Keith, UVM Professor Laura May Collado of the UVM Department of Biology, and UVM Senior Megan O'Connor. A reminder, UVM Research Week ends tomorrow, Friday, April 19th. Visit go.uvm.edu for activities and opportunities to meet and learn from UVM professors and students as they do the work, as the saying goes, of scientific research. From the cast and crew behind the scenes here at WCAX, I'm Jolie Whitney. Have a good one.